I cannot tell you how many times I've recorded this whole project, so I'm just gonna go through it. Okay, so it's a 7 meter by 5 meter section beams, right? We have a height of 7 meters, and we're separating by 5 meter intervals, right? Now, a man sits 10 meters past a point on A on the bridge. Assuming the man weighs 68 kilonewtons and gravity is 10 meters per second squared, find the following. Okay, so that being said, something to note: both sides of our bridge are static. Now, right over here, since A of x and G of x are basically fighting each other, not fighting each other, but they cancel each other out, thus the static. Otherwise it'd be dynamic, but besides the point. They are static, therefore they will cancel each other out in the x direction. Now as for the y, not as much. You still have to do some little bit of math for that. So in the f of y, we get our reaction forces at the point A and G, and then set them equal to 68 kilonewtons, right? And this will be our equation that we're going to be messing with mostly. So first we'll try to find our g of y. G of y times 30 minus 68 times 10 is equal to 0. And we can conclude that our g of y is equal to 22.67. Now as far as our a of y is equal to 68 minus 22.67, and we know that because of our previous equation when we plugged the g of y in. Okay, so then we take our moment at k, right? And then we find our force in BC, which we'll be mostly using this graph for that, BC, after we make a cut on the top. Now we find our LK when we take a moment at B, and then we have take our sum of the forces, and we find our force at AB by using our y, or the forces in the y direction. And then reaction forces, that's different. This is in the joints themselves to find our force at AB, which is this guy. Yeah, these are a little bit more difficult, mostly because of the angle that is implemented in this. And then finally joint L. And then we know that some of the force in the x direction is equal to 0 in this case, because we have to consider everything, not just the reaction forces. So here we have force at AB cosine of theta minus BC plus BK cosine of theta, right? This would be our bread and butter in our equation. Now of course we plug and chug, and we can conclude that our force at BC is equal to negative 64.76 kilonewtons. This is most likely compression, due to its nature of being a negative force. Negative forces means you're pushing together, whereas LK and BK will be a stretch. Okay, and that concludes my project for my bridge. Thankfully enough, I got a better camera, and compared to my project 1, this is a huge step up from quality. So I hope you enjoyed my project, Professor. You have a good night.